Integration by parts. Integration by parts can be thought of as the reverse of the product rule for derivatives. We use integration by parts on integrals of the form f of x times g prime of x. The formula says that such an integral is evaluated as f times g minus the integral of f prime times g. Our goal in integration by parts is to convert an integral that we do not see how to evaluate into one that we can evaluate more easily. Again, the parts formula states that the integral of f times g prime is equal to f times g minus the integral of f prime times g. This formula is easier to remember when it's expressed in differential form. We express it in differential form by making a simple change of variables. We let u equal f of x and v equal g of x. Then the differential of u, du, would be equal to f prime dx, and the differential of v, dv, would be equal to g prime dx. Substituting u and v into the formula, then we end up with the integral of u dv is equal to u times v minus the integral of v du. We will work with the parts formula in this form. Well, how do we go about determining u and v? Well, we'll choose u and v so that we end up with a simpler integral than the one we start with. We'll use the acronym LIATE as a guide for choosing u in the integration by parts formula. In order, check our integrand for the following. Check to see if there's a logarithmic function in the integrand. If there is, let that be u. If not, then check the integrand to see if there's an inverse trig function. If there is, let that be u. If not, check for an algebraic function, a trig function, or an exponential function. Use this as your guide for choosing u. Once you choose u following the acronym LIATE, then let dv be whatever is left over after u is chosen. We'll look at an example. In example 1, we're asked to evaluate the integral of 2x times e to the x with respect to x. Using LIATE as our guide, we check for a logarithmic function. There isn't one. We check for an inverse trig function. There isn't one. Then we arrive at a for algebraic function, and we do have an algebraic function. Our algebraic function is 2x. So we'll let u be 2x, and then let dv be whatever is left over. Well, the leftover part, if I let u be 2x, is e to the x dx. So I'll find the derivative of u. Du is 2 dx. Then I'll integrate dv to find v. V is equal to the integral of dv. Well, dv was equal to e to the x dx, and the antiderivative of e to the x is just e to the x. Now I'll apply the parts formula. Recall the parts formula says uv minus the integral v du. So u is 2x, v is e to the x. So I'll have 2x times e to the x minus the integral of v du. Well, v was e to the x, and du was 2 dx. So now I'll integrate that second term. The integral of e to the x times 2 dx, I'll rewrite that as 2e to the x dx. And again, the antiderivative for 2e to the x is 2e to the x. Putting it all together, the integral of 2x e to the x, I use parts and find that it is equal to 2x e to the x minus 2e to the x plus my arbitrary constant c. Example 2, I'm asked to evaluate the integral of x to the 4th power times the natural log of 4x with respect to x. Again, using LIATE, I see that I have a logarithmic function in my integrand. My logarithmic function is the natural log function, so I'll let u be equal to the natural log of 4x. Now that I've chosen u, dv is everything that's left over, so dv then would be x to the 4th power times dx. I use the chain rule to find the derivative of u. The derivative of the natural log of 4x is 1 over 4x times 4, which simplifies to 1 over x dx. Now I'll integrate dv in order to find v. V is the integral of dv, and dv was x to the 4th power dx. So the antiderivative of x to the 4th power is 1/5 x to the 5th. Now apply the parts formula. uv minus the integral of v du. Well, u was the natural log of 4x, and v was equal to 1/5 x to the 5th, minus the integral of v, again v was 1/5 x to the 5th, times du. Du was 1 over x dx. Integrating that second term, the integral of 1/5 x to the 5th times 1 over x, I can rewrite as 1/5 times the integral of x to the 4th power, and the antiderivative of x to the 4th is 1/5 x to the 5th, and remembering to multiply it by the 1/5 that was out front, I get 1/25 times x to the 5th power. Putting it all together, I get that the integral of x to the 4th times the natural log of 4x is equal to 1/5 x to the 5th times the natural log of 4x minus 1/25 x to the 5th plus my arbitrary constant c. When using integration by parts, remember to check your work. Check your work by taking the derivative of the final answer, and in taking those derivatives, each answer that you get as the result of integration by parts will require the use of the product rule. So you check your answer by taking the derivative, and in taking the derivative you will need to use the product rule, and check to see that you get back the original integrand that you started with.